Hi, madam and my friends. Today we would like to explain about the statistic and probability assessment for the daily number of COVID-19 cases in India, Malaysia, and Singapore. Then, our group member got 7 members. As you can see in here, the first one is the Justin Go with me, Go Wei Zi, Lin Le Xuan, me, Liu Wei Jie, Amil, and the last one is the Rama. Now, I would like to explain about the data for daily COVID-19 cases in India from 1 March to 2 May 2021. As you can see in the data, we will got the smaller value is 12286 is placed on 1 March 2021. And the larger value we got from the data is 401993 is placed on 30 April 2021, and the total cases is 8812886, and the number of observations for this data is 63. Then for this, we will use the Sugaru to get the number of cases K. Then the formula is 1 plus 3 by 3 log 63. Then we will got 6.94, and we will round off to 7. And the next one is the class width. The class width is the range divided by the K we got from here. And then we use the 401993 minus 122x6, then divide by K, which is 7. Then we will got 55672.43. Then we will log off it to 55672. And the next is the group data for our daily COVID-19 cases in India for 2 months. So now I will pass it to Rama to explain the left for the India. So that's for me. Thank you all. Bye bye.
Hello, I'm Rahma Hussein Mohammed Abdel Daim from section 27 in group 6, and my part is to explain the central tendency and dispersion in India. First of all, I would like to explain the graph, which, as you can see, illustrates the number of days took uh, to hit a certain number of cases for each range of cases, and in addition to that, each bar has a class width of 55,672 cases. Next, I will explain the central tendency, and I'll start with the mean, which is equal to the total frequency multiplied by the number of cases divided by the total frequency, equal to 9,152,943 divided by 63 will give us a value of 145,280.05. Next, the next thing that we will need to get is the median. First, we will need to calculate the median position, which is equal to the total frequency divided by 2, equals to 63 divided by 2 will give us the 31.5th position. So the median is equal to L plus half N minus F divided by the frequency multiplied by the class width, equals to 67,957.5 plus 63 divided by 2 minus 29 divided by 8 multiplied by 55,672 equals to 85,355. The last thing that we will need to get in the central tendency is mode. I will start with the mode class, which ranges from 12,286 to 67,957. And then we will need to get D1 and D2 for further calculations. So D1 is equal to 29 minus 0 equals 29. And D2 equals 29 minus 8 equals 21. So the mode is equal to L plus D1 divided by D1 plus D2 multiplied by the class width, equals to 12,285.5 plus 29 divided by 29 plus 21 multiplied by 55,672 will give us a value of 45,575. Next is dispersion. The first thing that we will need to calculate is the range, which is equal to the largest value minus the smallest value, equals 401,993.5 minus 12,285.5 equals 389,708. Next is variance, which is equal to the total frequency multiplied by the number of cases square minus the total frequency multiplied by the number of cases in between brackets square divided by n minus 1 equals to 2.34079 e plus 12 minus 9,152,643 squared divided by 63 divided by 63 minus 1 will give us a value of 16,307,961,114.84. The last thing that we will need to calculate is standard deviation, which is equal to the square root of variance, which will give us a value of 127,702.63.
Hello everyone, I am Goweiter from section 27 and I would like to share with you all about the compute the measure center tendency and dispersion of the dataset of India case in COVID-19. Compare and measure the central tendency among three countries, which is India, Malaysia, and Singapore. Based on your reading and on the current issue pertaining COVID-19, explain why certain countries have higher mean of the cases and vice versa. India has largest mean of case of COVID-19 among three countries. This is because the population in India is very large and dense. This might cause more interaction among the people and increase the chance to get affected. Besides, the management of the government was not effective enough to cope with the COVID-19. Moreover, the medical equipment in India was not enough because there is too many number of patients. There is also reason that the residents of the India do not follow the regulation made by their government. These reasons cause India the highest cases among three countries. Besides that, Malaysia has lower mean of cases as compared to India. This is because the population of Malaysia is not that large and dense compared to India, and the management of our government is more effective compared to them. But there is still people who doesn't follow the management of the government, which cause the cases is still increasing. Singapore has lowest number of cases because complete medical system and equipment. The management of their government are strict and also effective. However, the data above does not representative of all. This is because total population of each country is different. In addition, the number of diagnoses in each country is different every day. So the data will vary greatly, and national control is also one of the problem. In the B2, we find the interquartile range. By using the data above, we find the Q3, which is 48, and the class is from 234974 to 2906. 45. And the lower boundary of the class is 234,973.5. The cumulative frequency is 47, and the frequency of the class is 3. And this is the class width. Is still the same calculation way for Q1, which is 16, and the class is from 12286 to 67957. This is the class boundary, and the cumulative frequency is 0. The class frequency is 29, and the class width is same as the Q3. So we, using the formula, we find the Q3 value and Q1 value, and finally, to find the interquartile range, we minus the value of Q3 with Q1, which we get the result, the final result, which is the interquartile range. The final result is 197,092.138. This is the interquartile range. The B3, we measure and interpret the skewness of data set and explain brief distribution of data set and give comment on the difference of the distribution between the country and explain why. To measure the skewness, we use the formula skewness equal to mean minus mode divided by standard deviation, which the value of mean, mode, and standard deviation are calculated from above. We substitute the value into the formula and we find the number is 0.7885. So we found that the value of mode is smaller than median and smaller than mean. So the data set is positively skewed. Therefore, it is better to measure with median, as most data fall to the right and the graph has a peak at the right side. The histogram skew with a tail on its left side, and the data skew to the right because of the lower boundary, which is extremely low relative to the rest of the data. So this is all about in India, and here is all about my part. Thank you.
Hi, madam. I'm Nilotion from Group 6. I will explain about the daily COVID-19 cases in Malaysia. This table has clearly shown the COVID-19 cases in Malaysia from the 1st of March to the 2nd of May. The total cases is 114,260. The total number of observation is 63 days. The minimum daily cases of this 63 days is 941 on the 29th March, and the maximum daily cases is 3,788 on the 30th of April. The number of class and the class Y were calculated by using formula k equal to 1 plus 3.3 log n and the range divided by k. The number of class is 7 and the class Y is 407. According to the information above, we classify the data as this frequency table. The higher frequency is 20 days at the first class, which is 940 until 1,346 cases. And the next is this is the histogram graph of the COVID-19 cases in Malaysia from the 1st of March to the 2nd of May. X-axis represents the case and the Y-axis represents the date. That's all for me. The next part will explained by Amil. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum, madam. My name is Amir Said Noor and I'm a member of Group 6. And here today I'm about to discuss the calculation part of the COVID-19 cases of the country in Malaysia. So as my previous member has already explained the table, I'm going to explain the calculation part of it. So basically, first what we need to find is the simple mean actually. So for this, we need to find the summation of f into x, that is the frequency multiplied by the midpoint, then divide by the total of all frequency, that is the summation of all frequencies. Then we apply the formula, we substitute the values, and then we get 2097. And after that, we need to find median. First, before finding the median value, we need to find the median position. For that, we use the summation of f divided by 2, and then we get the 31.5. So this 31.5, it actually belongs to this row actually. So this is the median class. So after this, after we find the position, now we need to use the formula for median, so which is the lower boundary for median class L, then plus n is number of observation, f is the cumulative frequency, and then this c is the class width of the median class. So here we use this formula and we get the median, simple as that. After that, we need to find the mode class. For the mode class, first we need to find d1 and d2 basically. So the mode class is 940 to 136. First we need to recognize this one. So this is mode class basically. So after that, the mode class is the highest. So that class belongs to the highest one. So after that, we need to find d1 and d2. So d1 is the difference between frequency of model class and the class and the frequency class before it. So this one and before that, this one, this class divided minus this class. And for d2, it's the same thing, difference between the frequency of model class, but it's the difference between after the frequency class of model class. So that means this green one minus this yellow one. So after that, we get the values. So 20 minus 0, and here 20 minus 19, and then we get this, and then we have to use this value, this d1 and d2 here, to get the mode, actual mode. For this, we need to use L, which is the lower class boundary for model class, then C is the class width, we already know d1 and d2, and then we get mode. Okay. So after that, we need to find the dispersion. So first of all, we need to find range. Well, range is basically the largest value of the table minus the smallest value of the table. So 3788 minus 940, this is the answer. So after that, we need to find variance. So for the variance part, we need to use this formula basically, which is a separate column, summation of fx square, that's the total of fx square, this column, then minus summation of fx whole square. So basically this is fx square, this is the total actually, and this is fx whole square. So we shouldn't be confused about that. Okay, so that is the whole square of this column, and so like this part we do the whole square on it, but here we just use this value. So and then n is the number of observation, we substitute the values and we get this value. After that, we need to find standard deviation. Well, standard deviation is basically the square root of variance, so its relationship is like that. So here the formula is elaborated again, but we can simply square root this value of variance to get the standard deviation. Okay, so after that, we have the comparison of the three countries basically, Singapore, Malaysia, and India. So here are the means basically, and the mean is different for each country. So this question is asking why it's higher for some countries and why there's a lower mean for some countries. Well, basically, I'm comparing Malaysia and Singapore. So Malaysia has a higher mean cases of COVID-19 compared to Singapore. Well, this is because that Malaysia has a higher population, so this will affect the mean cases of the COVID-19. But in Malaysia, there are also different clans, different cultures, different types of people, different festivals. So if the people does not abide by the SOP rules, they do not follow the SOP rules. For example, wearing masks, avoiding social distances, avoiding gathered people, crowds, and maintaining social distances, using hand sanitizers and other alcoholic stuff to be clean. So if people does not follow those stuffs, this will lead to an increase in the case, which will like which will eventually increase the mean cases of COVID-19 in Malaysia. And another factor that could be affecting is that Singapore has a better medical facilities and equipments and better handle on the medical needs of the people compared to Malaysia. So on the other hand, Singapore has lower mean of COVID-19 cases compared to Malaysia. Well, this is because first of all, the government has maintained strict SOP rules. That is, wearing masks, avoiding social gatherings, maintaining a social distance of 1 meters, and then not going out. For example, if they just going out when it's necessary, like people not going out for unnecessary things, then washing hands with alcohol to kill the viruses, or using hand sanitizers, etc. So, and if they break the law, there are certain actions taken to be against those who are breaking the law. So that's why, and eventually Singapore has a better medical team and equipments and facilities for the people to fight against COVID. So this is the main reason why Singapore has a lower mean case of the COVID-19, whereas Malaysia has a higher mean case of COVID-19. So after that, what we need to find is the interquartile range, basically. So for that, first we need to find the k of Q3, that is the third quartile. So for that, we use this formula, where n is the number of observation, which remains the same, but I is basically the number of quartiles which we're using. For here, for example, we're using third quartile, so you will use the number 3. Here we are using first quartile, so here we will use the number 1. So after that, we find the k. We use this k value in the actual formula to find the third quartile and the first quartile. So here, n is the number of observation, k is the values which we find here. Then f is the cumulative frequency, c is the uh, cumulative frequency before the uh, third quartile class. Then we have lower boundaries, then c is class width. So we use this formula, and we substitute the values to get all the third quartile and the first quartile. And after that, to find the interquartile range, that is the difference between the third quartile and the first quartile. So we subtract these two values, and we get this value. After that, to get the semi-interquartile range, basically what we do is we divide the interquartile range value by divide by 2. So here 733 divided by 2, and we get the value. And here we take the whole number. Basically, we don't keep it in a decimal position. Okay, so after that, the end part, we are talking about the skewness of the graph. So basically, for the skewness, this is the formula, which is 3 multiplied by the mean minus median, the difference of mean by minus median, which we already found in the first part. Then divide by the standard deviation, which we also already found in the previous part. So after that, we get a value of 0.12. So that means that this is bigger than 0, which eventually means that the graph is skewed to the right. So because of that, so the least value is mode and the greatest value is mean. So that means the best measurement that we can take is the median, which is in the middle one. So now, since it's greater than 0.2, the graph is skewed to the right, which also means it's positively skewed. So a right skew distribution has a long right tail. Right skew distributions are also called positive skew distributions because it's towards the right, and that's why there's a long tail in the positive side of the number line. This also means that the mean of the graph is also to the right of the peak. Thank you so much, and I would like then this is my end of my presentation, and I would like to forward the next part to Justin. Thank you so much.
Thank you, Amil, for the presenting about the part B of the Malaysia. Now I'm Justin. I'm going to explain about the data and the table we made for the daily cases of Singapore. The data we collected is started from 1 March to 2nd May 2021, and this is the data. As you can see, this is the data, and The smallest value of the COVID cases in Singapore is 6, that is the the 9th of March, and the largest value that found in Singapore is 45 cases, that is the 26th of April. And how actually we determine our number of class? We determine our number of class by using Stroger's rule. That is this formula: k equals to 1 plus 3.3 log base 10 n. And n is the number of observed, that is number of observed is the data we collected for 2 months, and we just sub in the value, and then we get 6.94, and we round it off. The answer is 7. So we will have 7 classes for Singapore, the daily cases of COVID for Singapore. Besides that, for class Y, we are using the range of the biggest value, the largest value minus the smallest value. We're using 45 minus by 6 and then divide by 7, then we get 5.57, and we round it off, so our Y is 6. And this is the table, the group data for the daily COVID cases in Singapore. Then the next person is Rama. She will explain about the central tendency and dispersion for the daily COVID cases of Singapore. And that's all for me. Thank you.
Next, I will explain the central tendency and dispersion in Singapore. First of all, I would like to explain the graph, and the graph illustrates the number of days that takes to complete a certain number of COVID cases. In addition to that, each bar has a class width of 6 cases. Moving on to central tendency, I will start with the mean, which is equal to the total frequency multiplied by the number of cases divided by the total frequency, equals to 1279.5 divided by 63 equals 20.310. The next thing that we will need to get is the median. I will start by calculating the median position, which is equal to the total frequency divided by 2 equals to 63 divided by 2, and we will get the 31.5th position. So the median will be equal to L plus half n minus f divided by frequency multiplied by the class width, equals to 11.5 plus half 63 minus 10 divided by 22 multiplied by 6 equals 17.364. The last thing that we will need to get in central tendency is mode. I will start with the mode class, which ranges from 12 to 17, and we will need to get D1 and D2 to help us in further calculations. So D1 is equal to 22 minus 10 equals 12, and D2 equals 22 minus 11 equals 11. So the mode equals to L plus D1 divided by D1 plus D2 multiplied by the class width, equals to 939.5 plus 12 divided by 12 plus 11 multiplied by 6, equals to 942.63. Moving on to dispersion, I will start with the range, which is equal to largest value minus smallest value equals 45 minus 6, and we will get a value of 39. Next is variance, and variance is equal to the total frequency multiplied by the number of cases squared minus the total frequency multiplied by the number of cases in between brackets squared divided by n minus 1, equals to 1,637,120.25 minus 31,815.75 divided by 63 minus 1, equals 26,397.019. Next is standard deviation, and standard deviation is equal to the square root of variance, which is equal to root 26,397.019 equals 162.471.
Good morning, madam and my friends. I'm Vijay from Group 6. So today I will present about the Park Bay of Singapore. So the first question,
we need to compare and explain it. So I will compare two countries, which is India and Singapore. So you can see the India first. So India is the highest mean of the cases of COVID-19 among these three countries. So this because their population is very large and their India government is not cautious in its management. Next one, their people also divide it into different level. If your skin color is more brighter and your level is more higher, so the higher the rank, the more powerful and wealthy they are. So they are not susceptible to infection because they have a better environment and treatment. Inversely, the lower the level, the more easy to contain disease due to their hygiene issues. The last one is the people of India did not follow the regulation made by the government. Next, we see the Singapore. So Singapore have the lowest mean of COVID-19 cases among these three countries. So why? Because Singapore government has adopted very effective policies and preventive measures to prevent the virus spread widely. And the people of Singapore are also ready to cooperate and abide with the SOP. So they were keeping a distance of 1 meter, not going out when there is nothing to do. They are not gathering and they will wash their hands oftenly and so on. And the last one is Singapore has complete medicine system and equipment. So we see the next question. So the next question is find the interquartile range. So the interquartile range formula is Q3 minus Q1. So we can get a value of Q3 and Q1, which is 52.16 and 25.57. So put it in the formula so we can get the value of interquartile range is 26.59. So the last question is talking about the scootness. So the scootness, we have one formula. So the formula is mean minus V mod and then divide it by standard deviation. So we can get the value of mean is 20.310 and mod is 14.630 and the standard deviation is 162.471. So put it in the formula, we can get a positive value. So our scootness is positive. Our mod is the smallest value and our mean is the biggest value. So the data set is positive scoot to the right. So the best measurement is median. So the histogram screw in such a way that their right side is longer than its left side. So data screwed to the right is usually a result of a lower boundary in a data set. So if the data set's lower boundary are extremely low relative to the rest of the data, this will cause the data to skew right. Thank you.